Chapter 1, Introduction to Chemistry. First of all, how do we define chemistry? Chemistry is the study of matter and the changes it undergoes, and matter is anything that has mass and takes up space. We have three images here for three examples. First, we see a propane gas burner burning. So here, even though you don't really think of gas or air or anything in the gas state as having mass, it actually does. And this is undergoing a chemical reaction. This is undergoing combustion and burning. So the study of this would be the study of matter, therefore undergoing a change, therefore it is the study of chemistry. Now in this case we have two very different things going on here. We have a chemical reaction that we can talk about the reactants, the propane and the oxygen, and the products, the gases that are given off. We also have a thermal reaction going on here because, as most of you should be aware, fire releases a lot of heat. So studying that heat transfer is also an important part of chemistry. Not all reactions have to be chemical reactions, however. Here we have a glacier that is melting. So this glacier is going to be mostly water, or H2O, and as it melts, it goes from solid water to liquid water. That's not changing its identity. It's still water. This is going to be what we're going to call a physical change later on. Not all chemical reactions are big or impressive or things we really think of as being chemical reactions. Everyday things are also chemical reactions. The last image we have here is a group of nails that are primarily iron that have rusted. So this rusting of the iron on the nails to form rust on the outside, or iron oxide, is also a chemical reaction that we can study using chemistry. So let's go more into depth with these concepts. First, we'll talk about how we can classify matter as solid, liquid, or gas. Now, there are specialty states of matter such as plasma or superfluids, but we're going to focus on the three main ones for this introductory chemistry course. First of all, we define a solid as something that has a definite volume, maintains its shape regardless of its container, and has particles that lie close together in a regular three-dimensional array. This image I have here is a close-up animation of water molecules H2O, where the oxygen is shown in red and the two hydrogens are shown in white here. So this is a solid piece of water, which we usually call ice. You can see the molecules are in direct contact with each other, and they're in a regular three-dimensional array. This ice has a specific shape, and it cannot change its volume without changing its state of matter. If we heat up this ice, we go on to the next state of matter, which is liquids. Liquids still have a defined volume, but they can take up the shape of their container. If I now pour this liquid water into a container with a different shape, it would take on the new shape. These particles are still close together and in direct contact, just like with solids, but notice it no longer has its regular three-dimensional array. These things now have the freedom to randomly move around and slide past one another. If I continue to heat up this water, it moves into the last state of matter, which is a gas. Gases now have no definite shape or volume because they can expand to fill their entire volume of their container. And these particles are no longer in direct contact with each other. They're very far apart, and they have freedom of movement to move around randomly. So we can have solids, liquids, or gases, all of the same substance. So speaking of substances, let's talk about how we can define their properties. So first, we have physical properties. Physical properties are those that can be observed or measured without changing the composition or identity of the material. For example, the boiling point. If I wanted to know the boiling point of the water in the last example, I would heat it up until it boils. but it would still be H2O, whether it's in the liquid phase or the gas phase, so I technically did not change its composition or its identity. Same thing with the melting point. Same idea. I'm just undergoing a phase change without changing it. I can measure this melting point without changing its identity. Solubility. This would be like, how much salt can I dissolve in water? I can dissolve salt in the water, but I didn't change the fact that it is salt. If I wanted the salt back, I could just remove out the water, either by filtering it or boiling it off. Other things I can observe without doing any change, like its color. If I looked at an object, I could identify its color or observe it without changing anything. Or its odor. I could observe something's odor without changing it. So these are all physical properties. Now, some of these physical properties, such as the boiling point and melting point, do require a change to observe, and these would be physical changes. They alter the material, but they don't change its composition. These are generally phase changes, which are going between solid, liquid, and water. So we're familiar with the example I just saw, solid, liquid, and water vapor. Melting is going from the solid to a liquid. Boiling is going from the liquid to the vapor. If I reverse this from the vapor to the liquid, or the gas to the liquid, so the reverse of boiling is condensation, which you might be familiar with, such as the water that forms on the outside of a cold glass during a hot, humid summer day is condensation. It's the gas in the air condensing back into liquid on the outside of that cold object. And then going from liquid to solid, or the opposite of melting, is of course freezing. You can also bypass liquid and go from solid directly to water vapor. Well, generally not so much with water unless you really change your pressure, but we can do this with other substances. For example, carbon dioxide. One of the ways you can purchase carbon dioxide is in the form of dry ice. Dry ice can be sold oftentimes at grocery stores to use as a packing material when you need to keep something very cold for a long period of time, such as food when you're going on a camping trip. Now, this is a solid, but if you take that block of dry ice and leave it sitting out, it will start turning straight into the vapor or the gas without becoming a liquid. Here in this video you can see blocks of dry ice and you can see vapor coming off of it. We can speed this up by warming it up, and now you see a huge amount of vapor coming off of the solid carbon dioxide, completely bypassing the liquid phase. Now this is another example of sublimation. This is a compound called ammonium chloride that when heated turns into a gas without becoming liquid first. You can see the vapor coming out the top here. Now if you look very carefully on the inside of this glass test tube here, you can see that this ammonium chloride is going back to being solid on the inside of the test tube. This is the same idea as condensation, except instead of going into a liquid such as water on the outside of a cold object, this is going directly back into a solid on the colder glass up here that's further away from the flame. So this is the opposite of sublimation, and it is called deposition. So these are ways that you can change your state of matter without changing the composition or the identity of your substance. In this case, it's ammonium chloride, whether it's the solid or the gas. So chemical properties can determine how a substance can be converted into another substance, and this is going to require a chemical change or chemical reaction. For example, burning a piece of paper. Chemical changes are very different from physical changes in the fact that they are generally not easily reversible. It's very easy to reverse a physical change, as we just saw, melting and freezing, condensation and boiling, but if I burned a piece of paper to observe the combustion point or temperature at which that paper burned, which Fahrenheit 451, if you've read the book, hopefully you have, it's very hard to go backwards and take the products of that combustion, the ash and soot and the gases, and make it back into paper. In fact, it's pretty much impossible. Or metabolizing an apple for energy. Once your body has metabolized it, you can't really turn it back into an apple. Some chemical reactions are kind of reversible if you force it. For example, oxygen and hydrogen. Here I've got oxygen shown in the white, or red, and hydrogen shown in the white. If I combust them or react them in an explosion, so this is the explosion of hydrogen, think the Hindenburg blimp exploding, the reaction produces H2O, or water molecules. Now this reaction is technically reversible, but it would take a lot of energy to make these water molecules break apart back into oxygen molecules. But the point is, you are no longer the same thing you started at. In the beginning, we're oxygen and hydrogen. In the end, we're H2O, or water. We have changed the identity of the substance, and therefore we have undergone a chemical change. Let's classify matter. Matter can be classified as a pure substance, which is composed of a single component with a constant composition. Now, an example of this is table sugar or water. Both of these are pure substances, even though, as you can see from this image, sugar, which is a disaccharide, or two rings of saccharides, or such as glucose and fructose in this example, is very complicated compared to the little H2O molecule. However, both of these are pure substances because it doesn't matter if you have a teaspoon of sugar or a cup of sugar, you're always going to have the same properties with that sugar. You cannot break this sugar down into any simpler substance by any physical change. If you were to heat sugar up until it melts, you would just have melted sugar. It would still just be sugar. Matter can also be classified as a mixture instead of a pure substance. Now, mixtures have more than one substance. So if we take our water and our sugar from the last example and mix them together, we will get sugar water, or sugar dissolved in water. Now, as you can see in the image, we have our big old sugar molecules and our little water molecules. These can be separated by a physical change. If I were to heat this mixture up until it boils off the water, I would have the water and the sugar separated again. Now, they can have varied composition depending on the sample as well. Looking back at those pure substances, we can also classify pure substances as either being an element or a compound. Now, when we say element, you're probably familiar with the periodic table of elements, and that's a great place to start. An element has just one of those elements on the periodic table of elements. For example, aluminum, or Al, is an element on the periodic table. If you have nothing but Al, or aluminum, you are an element. This is a kind of pure substances that cannot be broken apart by a chemical change. There is no chemical change you can put aluminum through to break it apart into anything smaller. There are nuclear reactions that could do so, but that is a completely different chapter for much later on. But it's not a chemical change. Compounds are still pure substances, but they contain more than one element. For example, here we have a block of salt, table salt, or sodium chloride. We have two different elements present here. The green ones are shown as chlorine, and the kind of silvery whitish ones are the sodium. So this is a compound held together by chemical bonds that can be broken through a chemical reaction, but it is still a pure substance. So this would be a compound. So to review classifying matter, it's helpful sometimes to use a flowchart. So if we look at this flowchart, starting with matter, again, remember, matter is anything that has mass and takes up space. To determine how to classify it, let's ask a series of questions. If my matter can be separated by physical properties, yes, it's a mixture. No, it's a pure substance. If that pure substance can be broken down to some simpler substance by a chemical reaction, yes, it's a compound. No, it's an element. So let's try this out in a few different substances. Let's say I have a gold ring that is 24 karat gold. So, matter. Is there anything physical I can do to that gold ring to separate it? Now, if I melt it down, it would still be gold. So, no, it's a pure substance. Next, can it be broken down into simpler substances by a chemical reaction? Is there any chemical reaction I can do to that piece of gold to change it into something simpler than gold? No, gold is an element. There's nothing I can do. So therefore, no, it is an element. So I hope this summary helps you classify matter and has introduced you to the concepts of chemistry. In the next chapter, we're going to go more in depth about these compounds, learning how to name them, learning the atoms that make them up, and the different parts of the atom.